thank you so much for joining us today for our Health is Wealth speaker series, where the Good Life Healthy Living classes host a distinguished speaker every month to talk to our community about living better and longer. Every month, every Wednesday this month of February, we're celebrating Black History Month. So we'll have speakers that are focusing on African American health and well-being. My name is Sherilynn. I'm the program manager for the Good Life, and we're exercise and nutrition our medicine. We love to know where you're tuning in from, so please feel free to drop all that information in the chat. We'd also like to welcome all the folks out there that are joining us from Facebook Live. Welcome to all of you. And it's important that I tell you that the Good Life is a growing national program. It's being developed by a network of researchers across the country focused on supporting healthy aging. Together, we develop programming to promote healthy lifestyles and healthy relationships. We are dedicated to reversing the growing public crisis, health crisis of dementia affecting economically disadvantaged adults. We believe that the good life can be achieved by everyone. The Good Life and the Health is Wealth series are developed by UC Davis Alzheimer's Disease Research Center in the East Bay, the California Department of Public Health, the City of Oakland Parks and Recreation, and the National Institutes of Health. Before we get started, we have some tips to help you enhance your Zoom experience. So you'll see a small icon at the bottom of your screen that says chat. When you click on that, you will see a sidebar show up on the right. At the bottom of the sidebar, you can actually type in any comments or questions you have. We will have a chat monitor that will be there to answer any of your questions. If you want to click on the icon that is also at the bottom of your screen that says participants, you can actually see everyone's name who has joined us. We'll have about 20 minutes of presentation and about additional 10 minutes of Q&A after our speaker. And without any further delay, today we are honored and excited to have Dr. Sherilyn Cooke to join our discussion around vaccines and updates around the COVID-19 vaccine. Growing up in a large, close family in Compton, California, Dr. Cooke attended local schools and received her undergraduate degree in biology from Cal Poly Pomona and a Master of Public Health and Behavioral Science and Health Education from UCLA. After working for several years for San Diego County Departments of Health and Social Services, she returned to school at Stanford University for her medical degree and completed her internship and residency in primary care internal medicine at Alameda County Medical Center right here in our beloved city of Oakland. Since coming north to the Bay Area, she has called this home. Now let's welcome Dr. Cooke.
Thank you very much. Welcome, everybody. I'm so happy to see that you've tuned in to participate. And I'm just going to get right into my slides without any further ado. I am a primary care physician. That's what I do 90% of the time, but I'm also the president of Sinclair Miller Medical Association, which is an organization of African American physicians. So this is part of the outreach that we're doing because we are all very concerned about the impact of COVID-19 on our community. So I'm going to go ahead and start sharing my slides. And let's see that. Okay. All right. So COVID-19 vaccines, what do you need to know? Okay, share. We already learned a little bit about me, and the only other thing I have to add is that I have no financial interest in COVID-19 vaccines, just so you know that. But what do you need to know? We're going to focus on why the vaccine is important. How do the vaccines work? A lot of questions I get about are how did they develop so fast? Are there any side effects and are they safe? So the first thing is, why are the vaccines important? This is an electron microscope picture of a COVID-19 virus. So if you would just take a few minutes to take a look at that, and particularly pay attention to the red spikes. Those are called the spike protein, which is a structure on the outer surface of the COVID-19 vaccine. And it's really important to understand how, about that structure, just to know that that structure exists, because it's related to how it infects people and how we actually develop the vaccines. So why is it important? Well, as of February 9th, over 27.1 million cases of COVID-19 have occurred in the United States. And we've had 366,000 deaths, over 366,000 deaths. And that's up almost 100,000 from the last time I did this presentation on January 13th. So you can see, even though cases have slowed down, it is still escalating rapidly. And also, if we just look back at 2020, COVID-19 was the third leading cause of death between February 1 and December 19th in 2020. And if you think about it, in 2019, COVID-19 did not exist, so it wasn't on this list. So clearly, it's a leading cause of death behind heart disease and cancer. The other thing is that COVID-19 disproportionately affects communities of color, elderly people. Cases go up exponentially, or serious cases go up exponentially when you're over 65, over 75, and over 85. It also affects essential workers disproportionately, and also those who lived in cramped conditions. So if you can imagine, if you live in a household and there's just two people there, you're not going to get a lot of spread. There's two people, but if you have, parents, then you have grandparents, and then you have grandkids, you have 8 people in a house, clearly you're going to get a lot more spread in those conditions. And there also was a major outbreak in one of the chicken processing plants in the Central Valley, because essential workers, people had to go to work, they're in food processing, and they're working very close together in enclosed areas. So those are areas where it's just ripe for spread. I'm going to take a look briefly at a little bit of data from Alameda County. I'm going to have to stop sharing for just a second. And I'm going to pick up another share. Okay, so can everyone see my screen? If you raise your hand or something. Okay. All right, so this is what we call the Alameda County dashboard for COVID-19 cases. And I just want you to take a quick look at this. And if you focus in on this area here, a case rate is like number of cases per 100,000 population. So if you look closely at this, for Latinos in Alameda County, there's 8,380.7 cases per 100,000 people. And if you look down even further at African American, there's 3,519 cases per 100,000 people. So this is the number of cases. However, if you look at death rates, you will see that Latinos are 63.1 per 100,000 and African Americans are 101.6 per 100,000. So even though African Americans have a lower case rate of COVID-19, proportionately more African Americans are dying of COVID-19. And that is an important thing to you need to know about that. African Americans particularly are disproportionately dying from this disease. And there are a lot of reasons why. Of course, some of the underlying health conditions, such as hypertension, such as diabetes. Anyone who has a body mass index over 35, which is considered obese, are also more likely to die from COVID-19. So it affects everybody, it affects all ages, but it also affects different ethnic groups in a different way. Okay, I'm going to go back to my slides in just a second. Okay. Bear with me just a minute. I have to get my slides back up. Okay. So currently, there are only 2 approved vaccines for COVID-19 in the United States, Pfizer and Moderna. And both of them are extremely effective. There are a few more that are in the works. So the next question is, how do these vaccines work? And there's been a lot of publicity about these vaccines and how they work, and they're new. So any vaccine, including the COVID vaccine, teaches your immune system how to recognize and fight viruses that cause COVID-19 in this situation. And the thing about the new COVID-19 vaccines are they're using a technology which has not been used previously in a vaccine. And that technology is called a messenger RNA. So just so you know, our bodies make messenger RNA. It is a part of our immune system that all of us have. So I'm just going to go briefly through the science of how this actually works, but you start off with a coronavirus, which is at the top, the big red thing with the little orange spikes on it. So way back in January 2020, scientists were able to do the genetic code on this coronavirus. And part of that genetic code is the genetic code for the messenger RNA. And what messenger RNA does is it takes information into our bodies and instructs our cells to make something. We have to repair our cells all the time. You know, everyone has messenger RNA. It's making new cells. It's making new proteins in our body all the time. So what the scientists did is they took this messenger RNA from the coronavirus, and this messenger RNA has the code in it to make our body produce a piece of these spike proteins that are sticking out on that coronavirus. So those little orange spikes up there, I showed you the picture up front, up in the beginning of the presentation, they were red. But that's the spike protein. And the spike protein is the part that allows the coronavirus to infect and get into our cells. So this little messenger RNA has a code for our bodies to make a little tiny piece of this spike protein. And what that allows our bodies to do is to make antibodies. And everybody's heard about antibodies, which is what we need to fight this thing off. So, but you know, the question is, how is this different? Now, everyone has at least heard of the flu vaccine. So there's really 3 different types of vaccines available. One is called a protein-based vaccine. Number 3, which we talked about briefly, is the messenger RNA vaccine. And then there's called a viral vector vaccine. So we've gone through what happens with the messenger RNA vaccine. It takes a little piece, it takes the genetic code to make a spike protein. Our body actually makes that protein, and then our immune system can respond to that protein. The flu vaccine and basically all other vaccines which are currently available are considered protein-based vaccine. So this is like the flu vaccine. So what they do with the flu vaccine is they culture different strains of flu every single year. And they, you know, have to guess which ones are going to be out there that we need to be protected against. So they take a piece of protein from the flu virus and they kill it. They kind of stun it. They denature it. And then they put it into the vaccine and they inject it into us. So it cannot cause the flu because it's essentially a dead piece of protein. It's not alive, it's not infectious, but it's different. And our body says, that doesn't belong here. We need to get rid of that thing, and we start building antibodies against it. Just so you know, there are 2 other vaccines in the works. They are not yet available. One is Johnson & Johnson, and one is AstraZeneca. And the big deal about Johnson & Johnson, it's going to be a one-shot thing, whereas Moderna and Pfizer, the messenger RNA vaccines, are 2 shots. But what the Johnson & Johnson is called a viral vector vaccine. So it too takes some of the genetic sequence of that spike protein from a coronavirus, but it puts it into a cold virus called an adenovirus. They take the genetic material of the cold virus out. They put the genetic material to make that spike protein into that cold virus. They put it in a vaccine. They inject it into us. So again, our body sees this spike protein piece in there, which our body produces itself. And again, that activates the immune system. So all three of these things are really ultimately resulting a little piece of a spike protein from a coronavirus, which our body then mounts an immune response to get rid of it. So as I mentioned, pretty much all vaccines until the Moderna and Pfizer vaccine for coronavirus came out were what they called protein-based vaccines. So they're kind of, we call them attenuated, but they're basically a dead piece of virus that they can get that protein in that your body says, this doesn't belong here. Let me try to fight this thing off. And, when you get the shot. So that's how the flu shot works. Prior to the Johnson & Johnson and AstraZeneca, which are still pending, the only approved viral vector vaccine in the US is for dengue fever, which one might get if you go to some tropical country, you might get vaccinated against dengue. And then we have the Moderna and the Pfizer vaccines, which are available now. They're under emergency use approval. We think Johnson & Johnson and AstraZeneca will be approved soon, but they are not yet. But I just want you to know they work a little bit differently. So the next question you might ask is, well, how did these vaccines develop so rapidly? Because they're really fast, and a lot of people don't trust them because they're so fast. And particularly in the African-American community, it's pretty much normal not to trust new things that get out because of our history of being experimented on with things like the Tuskegee study, which dealt with, syphilis, a contagious disease, and many other studies where people were not forthright and upfront, and people were experimented on and they were tested on, and they were not knowledgeable about that. They didn't know that's what was happening. So I just want to go through how this thing developed and how this is different this time. So one of the reasons why the Pfizer and the Moderna vaccines were developed so rapidly is because they really are based on pre-existing knowledge. We knew the components, they just had not been put together. So one of the early scientists is Dr. Katalin Karikó, who was from Hungary. She immigrated, went to Philadelphia, and I believe she was at Temple University and worked with other researchers there. She's been doing research on messenger RNA since the 1980s. She's been in this field for almost 40 years, and she is one of the primary researchers on the Pfizer vaccine. She works for BioNTech, which is a small company that partnered with Pfizer to make their messenger RNA vaccine. So again, she's been working on it for a long time. And so the technology of messenger RNA is not new. It just has not been applied to vaccines. The other thing that's been going on for a long time is research around coronaviruses. Some of you might remember SARS, which was around from China, about 15 years ago, and also MERS, Middle Eastern Respiratory Syndrome, which is around in 2012. So even though COVID-19 is new, it is very similar to MERS and SARS, which have been around for over 10 years. And researchers have a lot of experience with working with these spike proteins because all of these viruses have the same type of spike protein. So you've got people researching the messenger RNA, you've got people researching the spike proteins, and you knew the genetic code for this way back in January of 2020. And the other reason is because they're just using the genetic code and using this messenger RNA, which they've synthetically manufactured, they don't have to culture viruses. Every year when they do the flu virus, they have to culture flu virus, which takes months and months and months to do to get next year's vaccines ready. One of the primary researchers around the COVID-19 spike protein is Dr. Kizzmekia Corbett. She works for the National Institute of Health. She has worked on MERS, she has worked on SARS, and she has been researching in this area with National Institute of Health for over 10 years. And she is one of the primary developers of the Moderna vaccine for coronavirus. And again, she's developed a lot of the technology around the spike protein and they quickly adapted it from MERS to go into COVID-19. This is an electron microscope picture of a coronavirus, which is purple on your left, and a human cell on the right. And you can see this little teeny thing called a human cell receptor is intertwined with this spike protein. That is how the coronavirus comes in to actually infect us. This spike protein is the key thing that allows it to get its genetic material into our cell to cause us to be sick. The thing about the vaccine is they have that spike protein, but none of the genetic material from the coronavirus are in the vaccine. So it cannot give you the coronavirus. A lot of people are concerned about manufacturing. I just want to mention briefly, there's 3 phases to get vaccines approved. Phase 1, where you're just looking at, does it work? Is it safe? It's just a few people. Then it goes into phase 2. If it pans out there, this might be several hundred people. They're looking for side effects. How are people responding to it? And if that is successful, then they go to phase 3, which is where they get hundreds more volunteers to do. What you need to know is that Moderna and Pfizer have gone through all 3 phases of these studies. I can tell you that once they got past phase 1, they quickly moved into phase 2 and phase 3 at a much more rapid rate than what they normally would, but all of these phases were done. And how could they do this? The bottom line is money. There is a lot of money and a lot of different researchers working on this all over the world at the same time. The US government spent over $4 billion. They invested in Moderna and supported their development of their Moderna vaccine. And again, we had this National Institute of Health scientists working with them. The US government agreed to purchase 200 million Pfizer vaccines, and this was even before they were manufactured. So the government didn't pay for Pfizer to develop it, but they agreed to purchase it. So there's exponentially more money put into this than there has been anything else in recent history because it's such a huge problem. So a lot of money. I mean, that's probably really the bottom line because researchers need money to do the studies to get these things approved. So side effects. I can say most people can expect a sore arm. You're going to have a little pain at the injection site. Some people have swelling. About half the people who get the vaccines might have headache, they might feel tired, muscle aches, joint aches, but the symptoms usually go away within 2 days. And they're not real serious. There are a few anaphylactic reactions where people really have a serious allergic reaction to the vaccine. And because of this, you're going to be monitored between 15 and 30 minutes after getting the vaccine. And there have been, a lot of these done so far. So the things to remember, the vaccine, the messenger RNA vaccines cannot give you COVID-19. There is no live virus in the vaccine. And that messenger RNA is literally dropping off a code for your cells to make a piece of this protein. But the virus itself and the genetic material of the virus itself is not in your body. It does not get into your DNA. It does not affect your own DNA. It's in the portion of the cell that just makes these little spike proteins that stimulate your immune system. So are they safe? Well, they do appear to be safe for healthy adults. We're monitoring for side effects, which is ongoing. And of course, further clinical trials are needed for other ages and conditions because they've only been tested on adults. And I can tell you in general, no new drugs, no new technologies are ever initially tested on children or pregnant women or breastfeeding women. It just doesn't happen. So again, Moderna is for 18 years and over. Pfizer's approved for 16 years and over. No studies on pregnant breastfeeding women or children yet. They're in the process. And the only contraindication is if you have had severe, life-threatening allergic reactions to a previous COVID-19 vaccine or some other condition where you just have a vaccine reaction where, you know, literally you're going to end up in the hospital. So mild, you know, swelling of your arm, that type of thing, that is absolutely not a contraindication to getting the vaccine. So when I say, is it safe? This is what I look at. Over 466,000 people have died from COVID-19. Over 13 million vaccines have been given. There have been cases of anaphylactic reaction, but they've all been treated. And so far, there have been no deaths proven to be from these vaccines. So I would take my chances with getting the vaccine versus looking at the astronomical amount of deaths from COVID-19. So I got the vaccine. One other just final note on this is, just because you do get the vaccine, you still need to protect yourself. The studies have shown that these are 95 to 94.5% effective from serious disease or death. So it is possible, if you become in contact with COVID-19, you might still get mild type cold symptoms, but it's possible you might be able to transmit that to someone else who has not been vaccinated yet. So because of, you know, even though you're not going to get deathly ill or land in a hospital, somebody else might if they have not been vaccinated. So we're still recommending that you shelter at home as much as possible. And the general consensus is, don't share your air. You want to wear a mask, be distanced with people when you're outside, moving around outside of your home. Don't share your air. Continue to wash your hands. And also, just a brief note on vitamins and vitamin D. I'm actually upping that from 2,000 to 4,000 IU daily based on some research that I just read yesterday, and I did not I didn't modify the slides, but there's some evidence about vitamin C, there's some evidence about zinc, and there's some evidence about vitamin D. And they're in general helpful for viral infections, but specifically COVID-19. So that is it. So I'm going to stop my share and come
well, thank you so
back and see if we have questions.
Thank you, Dr. Cooke. That was very informative. Thank you so much. We'd like to open up the chat now, or if you have any questions, please use the icons at the bottom of your screen and use your hand icon and raise your hand so you'll pop up at the top. But I'm going to start with some of the questions in the chat. Okay, Dr. Cooke?
Okay.
All right. So our first question comes from Deborah Finkler. And the question is there a provision to add any other type of vaccine that has been developed? For example, the one from Butana in Brazil is an old school type and much more affordable, a bit less effective, but still stops death and hospitalizations.
So I'm not familiar with that specific vaccine. What I can tell you is that the only two that are approved in the United States right now are Pfizer and Moderna. It looks like Johnson & Johnson is on its way. In terms of affordability, at least in the United States, the vaccines are provided by the federal government. You do not have to pay for the vaccine. So cost should not be a barrier at all to getting this vaccination.
Okay, thank you. And thank you for your question, Deborah. All right, our next question is from Cheryl Perry. And Cheryl's question is it true that the vaccine testing trials for Johnson & Johnson vaccine occurred among the indigenous people of South Africa? Good question.
Well, they did do some research with the Johnson & Johnson on the African variant. So yes, they did do some research in South Africa. And that's one of the things that Moderna and Pfizer have not specifically done, at least initially in their initial rollout, on the variants that you see around. So there were about 10% of the population in both of those companies' studies were African Americans. So there have been African Americans that were involved in these studies. But yeah, Johnson & Johnson did involve South Africa. So they kind of know, they've got data showing that it works on this South African variant, where Pfizer and Moderna at this point do not. But no, it was not tested exclusively on indigenous people of South Africa.
Thank you so much for answering that question. And our next question, I'm going to go ahead and go to some of our participants that have their hands up. And I would like to start with Patricia Richards. And you know how to unmute yourself. Let's see. There you go. Thank you.
Okay, let me move this off the screen. I had a couple of questions. One of them is I couldn't find the video, but there is a video where a woman did die. She went into this anaphylactic shock. She did have comorbidity and she died as a result of the vaccine, and her daughter was online. I don't have it, so I can't vet it right now. I can't put my hands on it. So that was one question, is that one woman who died as a result of having had it. She was obese, of course. And then my next question was, why are people having long-term effects from the vaccine? I've seen some things about fairly healthy people who are sick as a result of having taken one of the vaccines and having long-term effects, and it's all over media. And then I think that was all I had in my notes.
Okay.
And then I had another question. I was reading the circular this morning from the Moderna, and it said that it has not been approved. It was an emergency put on to approve it, but it really hasn't been approved. I don't have that document. I couldn't get it on my phone. I couldn't pull it up to read you exactly what it says.
Well, both.
I was searching for the circular from the vaccine. Now I didn't get to the
I'll start with the last question. So both Moderna and Pfizer are under emergency approval.
Right.
There have not been any that have permanent approval. They're all emergency approval. Okay, so that is true. In terms of videos that you see on the internet, I cannot speak to that specific video. I have not. But clearly there have been people who have died after the vaccine, but it hasn't been proven to be from the vaccine. When you vaccinated 13 million people, people are going to have heart attacks. They're going to have other conditions. So they have to research these cases to see, did they actually die from taking that vaccine? So that has not been proven yet. There are several cases under investigation, but just because there's a video on the internet that says, hey, they got the vaccine and they died from it, doesn't mean that's why they died. So that's, that's one thing. In terms of long-term effects, the vaccine has not been out long enough to have long-term effects. There have been people who have months-long effects from having COVID. They get COVID-19, they recover, but they still have long-term health effects from having the coronavirus. But that's not from the vaccine. I mean, the vaccine's only been out, what, a month and a half.
So they don't know yet.
No, we don't know yet, but there's not a good reason to think that there would be, because again, there's no genetic material. We know people have long-term effects from the coronavirus, but there's no coronavirus genetic material in these vaccines. The messenger RNA is kind of like a UPS truck. It comes in, it delivers the genetic code to make the spike protein, then it goes away. Your body actually dissolves the messenger RNA. And one of the reasons why it took so long to perfect the technology is because it was so delicate, it didn't last in the body. So they had to come out with this little fat layer. And it's technically called a nanolipid layer that surrounds the messenger RNA that prevents the body from breaking it down on the spot. So, but after it opens up and delivers that little message for you to make the spike protein, it goes away. So, and actually, I had that same question when I first started, and I called up one of my classmates who happens to also be a MD, he's a neurosurgeon actually, but he has a PhD in immunology. And they were doing a lot of research with this for treatment of cancer, trying to use messenger RNA to deliver things into the body to treat cancers. So he's the one that told me, he said, I'm not worried about long-term effects because your body just dissolves this messenger RNA very quickly. So, right. But again, 466,000 people have died from the coronavirus in the US.
Thank you for your question, Patricia. I'm going to go to the next person with their hand up, and that looks like it's Tony. So I'm going to ask you to unmute. Oh, jumped away. There you go.
Okay. Hi, how are you? Hi,
Good.
Dr.
Good.
Cooke. How are you?
Good. How are you?
Good. I have a question about the distribution. And why does it seem to be so uneven? The distribution seems to be so uneven. And why isn't the criteria for receiving the vaccine the same in all places? Like, I'm a veteran, and at the Veterans Administration, it's not until you're 75. And then there are other places and other organizations and other health, experts that say 65 is good enough, which I fall in that group. But what's being done about the distribution of this vaccine? Because it just seems to be so hard to get in certain areas.
Yeah, that's a huge issue. And the vaccines, again, all of them are purchased and paid for by the federal government. The federal government ships them out to the state health departments. And this is how it started out. And then the state health departments ship them out to the county health departments and like Indian Health Service and other entities. And then they get distributed out to various places to be given. So initially, there's not enough vaccine to go around, period. There just isn't. There's a shortage of vaccines, but different jurisdictions have established different criteria. So the state of California came out with their criteria for the vaccine, but say like, for instance, I read articles where an Indian Health Service, they're doing it at 55, they're doing it younger ages, but it's really up to the local jurisdiction of what the criteria is. I know in Alameda County, they're still on healthcare workers and 75 and above. And there's other areas that are already down to 65. So it's very frustrating. But yeah, it's not standardized at all.
All right. Thank you so much, Tony, for your question. Okay, I'm going to go to another question from the chat. And this question is from G. And it says, I think somewhere that the 2 vaccines being used have been authorized but not approved. Can you explain the emergency use authorized versus approved? From my reading, the testing proved the effectiveness of vaccines through the testing, that it is reasonable to give and take the vaccine.
So the emergency authorization is basically a mechanism where they can get the vaccine out because of the urgency and the seriousness of the problem. So obviously with people dying from COVID-19 every day, it's really urgent that we do something to protect people. So, you're correct. It's not fully approved, but it has gone through phase 1, 2, and 3. I can say in generally, like when medications come out, they have what they call a year of post-release surveillance. So even after new drugs have been on the market for a year, we still continue to report problems that you might have with them, a year out. So yeah, it's emergency. There's no way around that. There's nothing that has a final approval yet, but it's because it's so serious. But I'm confident in the safety of it. But do we know if there's going to be a problem 10 years down the line? We don't know 100%, but it doesn't seem like there's any evidence that there would be.
Okay, thank you. And thank you for your question, G. I'm going to go now back up to our gallery, and I'm going to unmute you, Sedalia, for your question.
Okay, I heard, can you hear me?
Yes, ma'am.
Yes, I heard that it could make you sterile. Have you heard anything like that? Or is it too soon? Because I do have a daughter who don't have children yet. I was a little concerned about that.
Yes, I have heard that rumor. And what I can say about that is, as I mentioned before, they don't test vaccines, drugs, medications, etc., on pregnant women or women who are breastfeeding. However, there were several women that became pregnant during the studies of Moderna and Pfizer. They became pregnant during that whole process when they were volunteers, and they have not had any negative outcomes from the vaccine. And from the scientists and the research that I've done, there's no mechanism really for the vaccine to cause sterility. So I think that that's something, you know, can we prove it? No, because we haven't had thousands of women get pregnant after they've gotten a vaccine, but it just doesn't look like there's a real scientific mechanism for that to happen.
Okay. Thank you so much for your questions, Sedalia.
Oh, and the American College of Gynecologists support use of the vaccine too. That's another thing. So the medical organizations that deal with pregnant women, they feel comfortable that the vaccine is safe.
Okay. Thank you, Dr. Cooke. And thank you for your questions, Sedalia. Okay, we have a lot of questions today. I love it. Okay, Arlene, you're next. You're in for it today, Dr. Cooke. All right, so there you go.
All right. Okay. Thank you, Dr. Cooke, for your presentation. It was very clear and cleared up a lot of questions that I've been hearing. I did have the vaccine on the 29th of January and had just a little soreness of my arm and nothing else. My sister also had it and she had very minimal issues. I just wanted to ask you, when you talk about approval or authorization, who does that? Is it the NIH or the FDA or who? But which agency is approving or authorizing the use of it?
It's the FDA.
Mm-hmm. Okay.
The Food and Drug Administration. Mm-hmm.
Right. Yeah. Okay. Thank you. I had another question, but I can't remember it now. So thank you for your.
I was just going to ask you, have you had your second shot yet?
I have. Oh yeah, I know what it was. I haven't had the second one. I'm getting that on the 26th. But in terms of, since I got the other one on the 29th, how protected am I now? Am I 10%, 15, 20, what?
You're about 80%. So
really?
You're about 80% and it bumps up to about 95% on the second shot. I do just want to point out on the second shot, people are tending to get more reaction to it. But if
I heard that. Yeah.
But if you think about it, on the first shot, your system's being primed. Your system has never seen this before. It's never seen this spike protein. It's like, what is this? Well, let me make some antibodies. So you start building up antibodies to it. And then 3 weeks, if it's Pfizer, or 4 weeks later, if it's Moderna, you get this second vaccination. And this time you've already got antibodies and your cells are kind of primed to it. They're like, hey, wait a minute, we know about this. We're coming after it. So they go to attack those spike proteins right away. So people do. So in a way, I look at it, this is telling me your immune system is working because it's getting activated and it's actively attacking this invader, which is this second vaccine, giving you more of these little spike proteins. They're primed and ready and they're waiting for it. Whereas the first shot, it was totally new for you. So that's why people tend to get more body aches, some joint aches. I had my second shot. I felt just really tired for a couple days.
Right.
And, you know, some people get fever. I didn't get fever. I didn't get chills. I just felt kind of fatigued and didn't feel like doing a whole lot, but that's about it.
Right. Yeah. I was followed by the CDC for a week after. So I had to check, they would check in with me every day.
Good.
And I had to respond to a series of questions from them about how I felt.
Yes, they are. You can sign up there. I can't remember what the website is, but there's a website where you can sign up, but they will question you. Yeah.
Right. Okay.
All
right. Thank you.
Arlene, for your question. I'm going to go to Rosemary, but Gail, I see your hand up, so I'll come to you next. And Patricia Hardy, I seen you had a question in the chat, so I'm going to go to you after Gail. Okay. Did you want to say it out loud, or did you just want it to be entered through the chat? Go ahead and unmute yourself. Oh, you are unmuted. Okay, Rosemary.
My question, I have my appointment scheduled for this coming Friday, the 12th, but I have a runny nose and I was wondering if I should cancel it. But, you know, I keep hearing that it is safe for healthy adults. And I have a lot of the systems. I'm well in the area of people that should be careful. I've got the high blood pressure. I am taking a drug that suppresses my immune system, a whole bunch of things that made me very nervous to take it in the first place. But I decided that I probably should. But now I've been having this runny nose, and I'm just wondering if I should call and postpone it.
Okay. Well, first of all, a runny nose would not preclude you from taking the vaccine. Now, if you have a high fever, that would. However, I just want to say a caveat. If you have a condition that suppresses your immune system, I would just check in with your physician to make sure it's safe for you to take. It's probably fine. I believe it probably would be fine, but I would check in with your doctor if you're on some immune suppression drugs. I would check in with them.
Yeah, they were. He suggested I take it. Well, I know.
Okay.
Well, he suggested I take the flu shot.
Yeah. I absolutely would not cancel it because you have a runny nose. Now, if anyone has had COVID, there is question about should you take the shot. And what they've come out with, the recommendation is if you have had COVID, you should wait 3 months after having coronavirus and then get vaccinated. You don't want to get vaccinated right after you've had it. You know, particularly if you've had a serious case like high fever, body aches, and have been really ill, you're going to want to wait 3 months and then get it. But no, colds, just a sniffle, stuff like that, you should go. I mean, because you're high risk, I would say absolutely you should go ahead and get it.
Thank you.
Mm-hmm.
Thank you, Rosemary, for your question. Gail Bell. Go ahead and unmute yourself.
Hi, Dr. Cooke. Thank you for your presentation. I had the first shot and now I'm scheduled for the second shot. And my question has to do with those adverse, you know, the anaphylactic shock symptoms. And I'm wondering if I should have somebody go with me when I take the second shot, and how long would it be before I might start to have some kind of reaction? Because I had heard that too, that with the second shot, you're more likely to have symptoms. Nothing happened when I had the first one. It didn't even, my arm didn't even get sore.
Oh, wow, that's great. So the anaphylaxis doesn't happen on the second shot. It happens on the first.
Okay.
And you will know within minutes.
Okay.
You will know within minutes. Yeah. And that's why they monitor you for 15 minutes. And if you're having a little bit of something, they're going to keep you a little bit longer. But yeah, no, the anaphylaxis happens almost immediately.
Okay. I was kind of trying to get a little bit scared. So.
Yeah, you know, hopefully you won't have the stuff the second time, but a lot of people are getting just tired, a little headachy, stuff like that.
Because I just, you know, I figured, well, I got through the first one.
Weekend. You're going to stay in and rest. That's about it.
Okay. All right. Thank you, Dr. Cooke. I appreciate your presentation was so terrific. My sister had contacted me from Connecticut to kind of warn me about it was doing something to my genetic code. And, you know, I had heard that one, and I wish I should have had asked if she could see it. It was a great presentation. Thank you.
So much misinformation out on YouTube and on the internet and on Facebook and on everything. And that's one of the reasons why I really feel strongly we need to at least try to, you know, put the information out there so people can know. Because, you know, I mean, disproportionately, again, African Americans are dying from COVID-19. And then you have all this misinformation out there that's going to keep you from doing things that can protect yourself.
Yeah. And then after taking the first one, then everybody's saying you're going to get, now you just said, now you're really going to get sick when you get the second. So thank you for reassuring me. Thank you.
Welcome.
Thank you.
Okay. Thank you so much. So it looks like Deborah, I can't see on my thing. It has a question. If you guys could make sure you're checking the chat. Has a chat, but it's too small on my screen, so I can't read it. I need it to come up on the side. Does anybody else have any questions? Sandra?
That's a good presentation. Thank you, Dr. Cooke. So my question is, I've heard after if someone had the virus, that the virus changes some of your DNA?
Mm-hmm.
Is
Okay.
that
Yeah, the virus doesn't change your DNA. Um, you know, you have an infection and your body has to build up this immune response to fight it off. But it does not actually, it's like there's viral DNA and then there's human DNA. And that's just, I don't even know how to say it. It's just not, it doesn't change anybody's DNA, whether you have the vaccine or whether or not you have the virus. I mean, there's been no pathogen that's changed our DNA. So
it just possibly give you some long-term effects of harder breathing and stuff like that? Because we've had
there's
a
been
few.
long-term heart effects. There's been long-term lung effects. There have been, they have it, they call it the long haul syndrome or other names for people who do tend to have chronic body aches, muscle aches, stuff like that after having COVID-19. So yeah, there's definitely some detrimental effects that could be long-term after having COVID-19, but it's not because there's been a change in your DNA.
Okay.
Chronic, mostly it's chronic inflammatory response. Your body becomes inflamed and causes all of these things.
Okay.
But they're doing research on that. This thing has not even been out barely a year in the United States. So there's just so much that we don't know yet.
Okay. Thank you.
Sure.
Okay, so we have several other questions, and we're going to try to get to as many of these questions as we possibly can, because there's a lot of questions in the chat. And this one is from Deborah. How do you feel about people building their own immune systems instead of taking the vaccine?
I think if you're trying to build your own you should try to build your own immune system, which is one of the reasons why I was suggesting, vitamins, vitamin D, vitamin C, zinc, which is a mineral. But I would not want to take my chances thinking I'm just going to build up my new immune system. So, 466,000 people have died from COVID-19. The vast majority of them are older, but you've had young, healthy people die from COVID-19. You've had a few children die from COVID-19. So, to me, it's a huge gamble that I would not want to take.
Okay, thank you for that question. And then from P. Howard, I had COVID in November. What's the recommendation if you've already had COVID?
3 months. You should still get vaccinated. And it's quite interesting. I didn't really expect this myself, but they've drawn blood on people who've had COVID-19 and they've checked their antibody levels. And then they check people's antibody levels after they have the vaccine, which is what they did during the experiments on the vaccines, when they were trying to go for approval. And actually the antibody levels are higher after the vaccine than when you actually had COVID-19. So that is why, even though you've had it, you may have some antibodies circulating in your system. They're still recommending you get a vaccine 3 months later because you'll be more protected.
Okay, thank you so much. Thank you.
And one other quick thing, we still don't know if this is going to need to be an annual vaccine like the flu. It's going to depend on how long the antibodies last. So far, it looks like it's at least 6 months, but we don't have enough data to know how long.
Thank you. And thank you for your question, P. Howard. Next question is from Gwen. Are you aware of an incident where there was one person that had the second dose of the vaccine and somehow contracted the virus after getting the second dose? Heard this on KCBS last week.
Mm-hmm. I'm not familiar with that specific incident, but if you think about it, the first shot usually is about 80%. So there's still a 20% chance you could get it. You get the second dose, that's not going to fully kick in for another week or two. So it's certainly possible. It's certainly possible, just like with the flu shot. But you think about it, a lot of you get the flu shot. The flu shot is only about 30 to 60%. So at best, 40% of the people are still going to get the flu after the flu shot. The COVID-19 vaccines are about 95%, but there's still that 5% chance. But honestly, they're much better than a flu shot.
Thank you. And thank you for your question, Gwen. And this next question is from Pam. The doctors who contribute to AARP magazine said to not take any aspirin or ibuprofen, etc., once you take the shot and feel a bit woozy because the aspirin makes the vaccine a bit ineffective. Do you think that's accurate?
Yeah, that's a good question. And there's been some controversy around this, but one of the things that COVID-19 does is cause inflammation. And when you get the vaccine, it's trying to boost an immune response. So you don't want to do anything to suppress that immune response. So I think the jury is still out on Motrin and aspirin, but I would say it certainly would be safe to take Tylenol if you have body aches, headaches, because that's not an anti-inflammatory. It's not going to suppress anything. So I'd say to be on the safe side, you could just take Tylenol. I think it's being debunked about the aspirin and the Motrin, but we don't know yet. It's still under investigation.
Okay. And then this next question is from Patricia. Sadly, a large percentage of people of color, Black people, have already died from COVID-19. Ironic how we are the lowest percentage of the population who has access to the vaccine. What is the plan to help Black people?
That is an excellent question, and it is going to vary everywhere, but I can tell you that it's well known. I mean, it was very upsetting to me that I found out that, one of the highest income zip codes in the United States, which of course does not have a lot of people of color in Florida, just about everybody there has been vaccinated. Whereas there have been other communities where vaccines are very low. One of the things that's happening is that the state health department is looking at areas where the vaccine, like Los Angeles County has way more cases than we even do here in the Bay Area. They're trying to preferentially send vaccines out to those communities. One of the things that I'm doing with Sinclair Miller Medical Association is Alameda County Health Department is interested in having smaller vaccination sites that specifically target the African American community, and we're going to be working with them. Now, whether that's going to be through churches, where it's going to be through senior citizen living communities, we don't have the exact dates or times yet. In the meantime, they're rolling out, doing the mass vaccination sites at the Coliseum, but there are efforts being made. I can tell you also, I actually work for Kaiser, and one of the things they're looking at is they're supposedly looking at vaccines through an equity lens. So they're also looking at neighborhoods where you live, and they're looking at, do you have hypertension? Do you have diabetes? Are you obese? And those people are going to be getting emailed to call up for the vaccine sooner than other people. So there are efforts being made, but clearly we are not getting vaccinated.
Okay. All right. So we have 3 more quick questions and then okay. So the next question is from G. Dr. Cooke, why the 3-month wait from having COVID-19 before taking the vaccine? Will the shot make the immune response occur quicker?
Okay. So I think, there's research out, but I'll tell you my take on it. And I'm not an actual expert on this particular question, but after you have the COVID-19, you do have antibodies circulating in your system. They're going to fade down over time. So, one thought might be if you wait the 3 months, you're going to be more protected after the 3 months before you boost it up again. The other thought is, if you think about when you get the first shot, you don't typically have a whole lot of reaction, but when you have the second shot, you do. So if you go in and vaccinate somebody while they're having a lot of antibodies out there ready to fight this, and it sees this spike protein, it's just going to attack. So I think you would probably tend to get sicker with a vaccine soon after you had COVID. So yeah, but they have come out with a recommendation of waiting 3 months, but still get vaccinated because it's going to give you more immunity than just having COVID itself.
Okay. And then we have another question from Deborah. How many people have recovered from the virus without taking the vaccine?
Oh, thousands. I mean, I don't know how many people have recovered from the virus without taking the vaccine. I mean, the thing is that I have to look at my numbers. I think it's like 37 million people have had COVID, and 466,000 people have died from it. So the vast majority of it have recovered. But some of them were in the ICU, some of them are having long-term effects. If you look at the percentage wise, it's less than 1% of people die from COVID, but it's still almost 500,000 people. So it's because it's spread so broadly that, the vast majority of people are going to recover, but a lot of people are going to die.
Okay, so we have one more question in the chat and then one more person on the gallery. And so Tierney's question is, how much mercury is in the vaccine?
0.
All right.
There's no mercury in the vaccine.
Okay, thank you. That was an easy answer. And then I'm going to unmute. So whoever this is that says iPhone, we're going to go ahead and unmute you so you can ask your question.
Or can I follow up on one thing though? When I say the vast majority of people that recover, I can tell you that the death rate is significantly higher in older populations. The death rate is significantly higher in African Americans. I don't have those exact numbers, and they actually change by where you are in the country. But again, when you say who got COVID, you have kids, you have young folks, and there's tons of people in their 20s and 30s are getting COVID. They've got the most cases, but they're not the folks dying. But I can tell you, seniors are the folks dying. We'll start with that. And African Americans, people with hypertension, with diabetes, with obesity, all of those things, those are the folks who are dying from COVID disproportionately, well above the other ages and races. So.
Thank you, Dr. Cooke. And then that last question from whoever's.
It's Pamela, me. Hi, Jeanette, I'm right outside. The question I have is COVID related to children. My husband's a teacher, and he works for San Francisco Unified, and there's this big controversy about, teachers don't need to have the vaccine because children aren't passing it on to them. But my husband over the years has come home with many a cold because, he works with younger children, 3, 4, 5-year-olds. And, those little ones always have runny noses. And my husband has always, had a cold. And so I'm really concerned about that and how dismissive they seem to be about protecting teachers in this big push to, get everybody back in school. I want the children to get back in school. Of course, I am a champion of education, but I want everybody to be safe. And so what's the take on that? I keep hearing, well, children don't get COVID. That's not true. Children get the flu. So that's my issue there.
Yeah. So children do get COVID. They don't get as serious of an illness as older people get. And the whole issue of teachers not needing the vaccine, there was something that came out that said the schools reopening should not hinge upon teachers being vaccinated. But I can tell you, personally, I would like to see the teachers vaccinated. Yeah. According to California, I believe they're in tier, I'd have to look it up. It's either 1B or C or 2A, but they're after they're after healthcare workers. They're after folks over 65 and 75. And I think they're with ages 65, they start opening up essential workers because teachers are considered essential workers. It's going to be interesting to see what happens. I think a lot of it's going to have to do with the teacher. I mean, if you have a 35-year-old healthy teacher, that's going to be different than a 65-year-old teacher. And
my husband is a 65-year-old teacher. He's 66. Yeah.
I mean, personally, I would like to see him vaccinated before he goes back into the classroom. Yeah. No question about that. So, honestly, I don't know. It'll be interesting to see how it pans out, but I don't think anyone is saying that the teachers don't need the vaccine. It's just that there's such a shortage of vaccine. The approach has been, let's give the vaccine to the people who are most likely to die, which is starting with people 75 and over. The older you get, the higher your likelihood of dying from COVID. So they're starting with 75 and over, going down to 65 and over, and then getting into essential workers. But yeah, I mean, teachers need the vaccine, but some of the school districts may try to open before all the teachers get vaccinated. But honestly, it'll be interesting because I know the teachers' unions are certainly pushing back on that.
Yeah, and there's a shortage of teachers, and a lot of the teachers that are available are older. And so it's like this big quandary. You want these teachers to go back, but a lot of them, are older, up in age. Because there is
it's very different because I know people down in the Los Angeles area who are teachers who've already been vaccinated, and they're under 50. So again, different jurisdictions are rolling it out in different ways, but teachers are certainly high on the priority list, but they're not the highest.
Yeah. All right. Thank you. I really enjoyed your presentation. So informative. Thank you.
Good. Thank you.
Absolutely. Yes. Thank all of you. Thank you so much, Dr. Cooke, for your amazing presentation. Very informative. We really appreciate it because obviously, as you can see, we have a lot of questions around this topic in our community. So it's better for us to be educated about it so we can operate from that place. So thank you again for spending time with us, and thank all of you for all of your really amazing questions.